Hey guys, this is CHEMPLIFIED and in this video we will talk about standard electrode potential. The symbol which we will use is E0 cell. It is also called by the name EMF of the cell. Now our topic standard electrode potential consists of three different terms. First one is standard. What is the meaning of standard? Generally in chemistry, whenever we talk about standard, we mean to say that temperature that we are going to take is 25 degree centigrade or 298 Kelvin and pressure is equal to 1 atmospheric. Now by using the term standard, we are just fixing the value of temperature and pressure. Now the last term is potential. What is the meaning of potential? Potential simply means separation of charge. Whenever there is a separation of charge, that is creation of positive and negative, there is a potential difference between them, and we are going to calculate that potential difference in the form of our E0 cell, right? Now the middle term is electrode. Let us take a look at this diagram. Now in this diagram, this is our electrochemical cell, and in electrochemical cell category, this is our Daniell cell, that is the cell between zinc and copper, right? One second. This is our Daniell cell between zinc and copper. Now in this cell, this is our zinc rod and this is our copper rod. Now we can also call it zinc electrode, copper electrode, right? So the electrode which we are talking about is our zinc electrode and copper electrode, or any other electrode which we can use in electrochemical cell. Now so our topic is standard electrode potential. Now we can define standard electrode potential as the potential difference in this case, in our case, the potential difference between zinc electrode and copper electrode at temperature is equal to 25 degrees Celsius or 298 Kelvin, and pressure is equal to 1 atmospheric, right? So potential difference between the two electrodes at temperature 25 degrees Celsius and pressure 1 atmospheric pressure, right? This is our standard electrode potential, simple definition. Now let us go towards the formula, but before we move towards the formula, there are a few things that you should know. I hope you are familiar with this trick. LOAN. L means left, O means oxidation, A means anode, and N means negative. In Daniell cell or in an electrochemical cell, it is general trend that on the left hand side we put that electrode which will undergo oxidation, and we call that electrode as anode, and the charge which is provided to that electrode is negative. So in this case, zinc is undergoing oxidation, copper is undergoing reduction. Zinc is our anode and it has a negative charge. Opposite side will be right, reduction, cathode, and positive, right? Remember this trick, LON, we will use it. Now you should also know what is the meaning of oxidation and reduction. Oxidation, you can recall this with the trick. Oxidation is loss of electron. Oil oxidation is loss of electron. Now if oxidation is loss of electron, then reduction will be gain of electron, because they are opposite of each other, right? So remember this trick. And now we will move to our formula. This is the actual formula to calculate standard electrode potential of any cell, of any electrochemical cell, which is equal to sum of reduction potential and oxidation potential. Now what is the meaning of reduction potential and oxidation potential? Let's take a look at this diagram. Now I hope you know the trick, LOAN, right? Now since zinc is undergoing oxidation, it will provide oxidation potential, and since copper is undergoing reduction, it will provide reduction potential, So you know from where you are going to get these values. Now what is the definition of oxidation potential and reduction potential? In simple terms, you can say that oxidation potential measures the tendency of an element or anion to lose the electrons. So it is just the measure of the tendency to lose electron. In simple terms, if zinc is undergoing oxidation, zinc will lose electron, and you all know this equation. Zinc will give Zn2 plus 2 electron. Zinc will lose 2 electron, and since copper is undergoing reduction, copper will gain 2 electron provided by zinc give copper solid. In this case, zinc is our solid, right? So this is our oxidation reaction, this is our reduction reaction, right? The potential which we are gaining, which we are getting from zinc half cell, it is our oxidation potential, and this side is our reduction potential, right? So that's how you get the oxidation potential and reduction potential values. Now we have to solve these in our numericals, right? But there is a simple problem with this formula, and the problem will arise when you look at this table provided in most of the textbook. The table is this. In this table you can see, let me change the color. In this table, these are the values which are given to you, right? It starts from positive and it ends in negative, and this is the arrow which shows that this values which are in the bottom of the table gives the value are of strongest reducing agents, which means lithium is the strongest reducing agent, and upper values are for stronger oxidizing agent. It means fluorine is our oxidizing agent. Now since I am using the term agent, it means fluorine is strong oxidizing agent, but it will undergo reduction. It will undergo reduction itself, and since lithium is our strong reducing agent, it will undergo oxidation. The trick will lie in this kind of things also, this kind of things only. I will tell you the trick really soon, just wait for some time. Now the values which are given in this table are standard reduction potential values. Standard reduction potential values. Remember the term standard reduction potential. All these values are of standard reduction potential, but the problem with our formula is that in our formula we are provided with reduction potential and oxidation potential, but in the table only reduction potential values are there. Now how we are going to solve this issue? Just remember that oxidation potential of any element is equal to negative of reduction potential. If you want to change the value from oxidation potential to reduction potential, just put a negative sign. For example, there is a value, oxidation potential value is 0.74. So the reduction potential for same element will be minus 0.74, right? Remember this. All right. So let's change E naught reduction potential minus E naught reduction potential. Now again the problem arises, we have two reduction potential values. Which value is for which one? You have to figure it out. Now let's take a look at the diagram again. I hope you remember this, LOAN. Now since zinc is undergoing oxidation, it will give you oxidation potential value, right? Zinc will give you oxidation potential value. Anything which is undergoing oxidation, will give you oxidation potential value, and we call that electrode as anode. Now we will use the term anode in our formula. Let's put that in the formula. Now in place of reduction potential, now this reduction potential was for cathode, so you will write E naught cathode minus E naught anode. Anode is the place where oxidation take place, cathode is the place where reduction take place. Now you can ensure that this formula will work, right? Let's take a look at a few examples. Before that, let's take a look at the table. Now look at this table. This is our table. All these values are reduction potential values. We will use this standard reduction potential values to solve our numericals, right? Let's take some examples. Now we will talk about our trick. Now this is our first example. This is our formula. Now just by looking at the values you can decide which one is cathode and which one is anode. Always remember the one in electrode potential, to find the value of electrode potential you will be provided with two values, right? Just like this example. Now just find which one is lower value. In silver and copper, the standard electrode potential of copper has lower value, right? Both are positive values. 0.34 is less than 0.80. So you just write that copper is undergoing oxidation. The one which have a lower value will undergo oxidation, and you know that oxidation takes place at anode by your trick LOAN, right? Oxidation will take place at anode. Just remember, lower value will undergo oxidation. Since this value is lower, you can say that copper will undergo oxidation and silver will undergo reduction. So since copper is undergoing oxidation take place at anode, and in your formula anode is right here. So you will write the value of copper at the place of anode. You will write minus 0.34. Now in place of cathode you will write the value of silver. You will write 0.80. Just solve it and you will get the answer. (0.80) minus 0.346 0.46 volt. This will be your answer. I hope you understood. Let's take another example. Now in the previous question I took two values which were positive. In this question I have taken two values which are negative. Now which one is lower value? In this case this is our lower value, minus 0.26. This is our lower value, which means it will undergo oxidation, and oxidation take place at anode. This will undergo reduction. Reduction take place at cathode, right? So put the value of anode at anode and cathode at cathode. This is our anode, so you will write minus 0.26. Cathode value is minus 0.13. Solve it. 0.13 plus 0.26. After subtracting you will get 0.13 plus 0.13 volt. So this will be your final answer. I hope you understood. Let's take a look at the table once again. Now this table, if you look closely, the table which provides you the value of standard reduction potential, this table is in decreasing order, right? This is the highest value, and right, this is our lowest value. This is the highest value, this is the lowest value. Now this table is in decreasing order, the values are decreasing, right? I hope you understood. Now remember, the trick to find electrode potential really quickly is that the lower value will always undergo oxidation. Suppose the cell is between copper and tin. Since tin have a lower value than copper, tin will undergo oxidation and copper will undergo reduction. In case of oxygen and copper will undergo oxidation and oxygen will undergo reduction. Like that you have to see the table, right? Generally the metals will come from this part. Lower the value, it will undergo oxidation. Lithium will displace this table also describes which element will displace which element. Now let's take a look at it again. This is the strongest reducing agent, right? Strongest reducing agent means it will help other to undergo reduction, right? And for that it will undergo oxidation. So whenever lithium is there, it will always undergo oxidation, and whenever fluorine is there, it will always undergo reduction, right? Like that you have to remember. Just try to understand the simplest trick. Lower value will always undergo oxidation, and oxidation takes place at anode. And write the value at anode and solve the numerical. Right? I hope you understood. This will be it for today's video. Thank you very much for watching.